European time, it's 31 past 1 at night. So I hope I'm not as sleepy as you are. I'm going to do a talk on mobile security. So it's a little bit different from wireless security that a lot of people are talking about. I'm talking about mobile on my phone. I'm not even so much talking about mobile on my PDA or something. This is mostly concerned with mobile phones. In front it also said, or on the list of today, it says also GSM. I won't be talking about GSM very much today. That's a little bit of a mistake. However, I do have some information on GSM with me from Emmanuel Gade, if I pronounce his name right. He was supposed to do a talk here on GSM security, on interception, and all the tricks that you can play in GSM networks. So if there's interest, maybe afterwards we can do a quick look at some stuff that's concerned with GSM. However, today I'm only going to talk about SMS and WAP. Now let's see if this thing is awake. Move. I don't believe you. Okay, so what I'm going to talk about. First, I want to go a little bit into mobile security. Just the general things that spring to mind when you start thinking about security aspects of a mobile device like a telephone. Then I want to talk a little bit about, okay, what am I talking about? What are all these terms? And next, there are the two parts. I go into detail about what is SMS, what is WAP, what are security aspects of it, what can you expect other than what you generally hear on security, which is mainly encryption. And then a little bit into the future of what we can expect. So, to set a little bit more of the context of the talk, as most of you probably know, SMS and WAP is mostly a European, Asian thing at the moment. I'm not so much informed about the situation in the US. I know that both protocols are not tied to the underlying GSM or CDMA or whatever protocols. But if you look at the usage, it's primarily in the European and Asian markets. So I'm not going to talk about the underlying technologies, as I said. I'm also not myself a web implementer or something. I don't build web gateways, I don't build infrastructure, I don't build applications, and I don't do security design or any kind of stuff for this kind of market. So don't expect advice very much in that area, although I hope, of course, that you can learn something if you're in that area. I'm also not going to demonstrate any exploits. I'm not going to show how I have built a virus that will spread to all your phones at this moment, so don't worry. So what will I be talking about? First of all, it's a general perspective, so I'm not going very much into one typical exploit that you could create against these technologies. It's more a general perspective of all the issues that are involved, how does it work, and where are aspects that are weak of it. How can I talk about something like this? Why would I be a person to talk to you about this? Basically, just as well, I guess, for me as for you probably. The only thing that I have is about 10 years of experience in hacking applications and systems. I have a pen test company in Holland, and that's my work. I enjoy it, I like it, and it gives me a certain view on systems where I approach it differently than a typical application builder would, or something, someone that wants to do a certain function with a typical application or technique works differently from someone like me who just wants to break it. And I hope to give you some viewpoints of areas where you can expect problems, where there may be problems in the near future when they start rolling out stuff like this, maybe even in the US. So, when would you be interested in a talk like this? My view of an audience that I'm trying to reach with this talk is people that are interested in or asked to evaluate security of these types of platforms. If you are asked to pen test a web gateway or platform or application, generally you need to delve into it pretty much from scratch because no one has done it before. So maybe with some pointers that I'm giving today, you know better where to start. Another part is that there's really very little information known on the protocols involved and the security issues involved, because everyone using it at the moment is trying to build stuff with it. They are just happy if it works. I mean, no one cares or has knowledge about the security issues that are potentially there. So what we need is people doing research into it and show what the issues are, and I don't know, maybe even write the exploits for it. So maybe I can reach some of those people. And of course, the general public that needs to tell people about issues, security issues with these kinds of technologies. So if you're asked to advise on the uses of these kinds of applications. Okay, mobile security. These are some points that I find, or how do I say, spring in my eye if I look at the mobile security of phones and the way that the people that build applications for them and use them deal with them. The first thing is the enormous difficulty with the user interface. Everyone is talking about encryption and authentication and that the protocol levels crypto is okay and that it will talk to each other in the correct way and that there's no way that you can, you know, put something in there to make it break. So, okay, all the lower level protocols are theoretical okay, but how is the user ever going to know if you have, you know, a screen size of I don't know, what's 20 characters by 3 or 4 or 5 lines? How are you ever going to know that you are talking to the right party? If you even have trouble explaining to people how to use their browsers on their Windows PCs. So I think this will be always one of the biggest problems with mobile devices. Then if we look at the standards that people are writing for these kinds of protocols and these kinds of technologies, you'll see that they omit all the security issues except for that encryption part or that maybe that authentication part. So as soon as it starts to get into the sensitive areas of I don't know, sessions and session IDs and how to deal with how to display your information, there's no information at all in standards, and everyone is free to do whatever he likes, resulting in like 100 different implementations and you know, intuitive things that are different, so no one knows what to trust anymore. And then a third point is that we're creating general purpose platforms all over again with all the associated risks. You know, if I have a general platform where I can run any code and mobile code, and you get all the problems that come with it, you know, you can't trust anymore, just like your PC, if you're home banking and surfing at the same time, I mean, it's hell. I mean, you don't know what you're doing, and there's no guarantee at all about security. So what I see in the mobile world is the same thing. There's no way that the platform will ensure correctness or integrity or something like that at all. So these are general mobile issues. Let's go more into the protocols and the technologies that I want to talk today about. First of all, you have GSM. GSM is one of the few standards that are out there for mobile phone about the lower layer to make the connection of your phone. So it's basically talking about how the phone is sending its signals to the base station and to a switching center, and that technology to make your call. So it's pretty low level. There are several technologies. GSM is big in Europe and in Asia. TDMA and CDMA are two competing style implementations here in the US, and GSM now slowly coming into the US also. If we talk about SMS, SMS stands has nothing to do with Microsoft, I don't know, management stuff. It's a short messaging service. It's a paging style message. So it's the old style message where you have paging in a new format where it's a digital message. WAP stands for Wireless Application Protocol, and it's pretty much a simplified HTML for small devices. So that's the terms that I'll be using. Immediately when you start looking into these protocols, you hit upon standards. There are several, how do you say it, groups or platforms or forums involved with writing the standards for these technologies. First you had the GSM standards, those were the original standards, I think 10 years, 15 years ago. They were specified as GSM, and then XX is a number, dot another number. That's the specification of the documents. Then they moved to the European Telecommunications Standards Institute. They have a special mobile group, so they moved the whole numbering scheme to ETSI and renumbered. So you have now documents with two numbers on them, the ETSI number and then the old GSM number. And now lately with the UMTS, there's a new platform. It's called the Third Generation Partner Program, where ETSI is a member, a few Japanese, Korean telecommunication standardization companies or organizations are members, and I think T1 from USA is also standardization, is also a member. And they again introduced a new numbering scheme, moving the ETSI numbering scheme into their numbering scheme, so you have now 3 numbers for every document. So it's a big heap of documents. And there's a separate, and that's pretty separate, standardization, and that's the WAP forum, which is doing all the standardization for web-related stuff. The most important major releases are WAP 1.1 and 1.2. You've now phones in both standard levels, and 1.2 obviously gives you more capabilities and probably more risks also. Okay, questions so far? That's good. SMS. Short overview of the points that I want to walk through with SMS. Okay, anyone familiar, not familiar with SMS? It's not at all. Okay, it's you have a phone. What you do is you type a phone number. You have write message. You have your keys or your letters. So you can enter your text. Pretty nice in the new phones. You have T9. It's a library encoding kind of thing. It predicts what word you want to type from the library dictionary that's in there. So you don't type 3 times the 2 to get a C. You just type the letters that are on the 2. So if you want to have a C, you just press once for 2. Maybe an A will appear, but if you keep typing, it will find the word that you are looking for and then form the word, so you have less typing. Anyway, so you type on, in the end your message is done, and you press send and it sends it off. And then we'll get to how it gets to your phone in a minute. So it's just sending a message. But, and it's also important, it's also used for some signaling to your phone in case of voicemails, for instance. It can be used to indicate a voicemail. It can even be used to indicate email. There are standards that already describe special SMS messages to do that. So, again, SMS is a store and forward messaging principle. It's either point-to-point or cell broadcast, so it can be like a multicast packet. You can send it from a cell and all phones get the same message. It's delivered through the SS7 signaling between the telephone switches. It's in a parallel signaling to the normal call. So if you're calling, you can still receive SMS messages in parallel. It's 150 bytes data, but normally the coding scheme is 7-bit, so you get 160 characters. So that's a normal size for an SMS message maximum. And you can send basically from anywhere. You can send from your own phone, but there are also all kinds of interfaces to the central point that sends the SMS, the SMS servicing center. And that can be a PC dial-in, X25, TCP/IP, whatever. So there are all kinds of interfaces to the SMS centers. And as I said, you can find all the specifications of the internals at Etsy. So if you look at a little scheme of the network, by the way, all the pictures that you see in my presentation, I stole all over the place from all kinds of documents, so I don't know whose this is. What you see is the blue things are the short message entities, so there's the mobile phones. They connect to the SMSC, the service center, which has a connection to the mobile switching center, MSC, which is doing a lookup, and this is already very tied to the GSM level, where it does a lookup in the home location register, which is a big database that says who's subscriber, where he is at the moment. And then the SS7 signaling uses that information to route the message to the end user, or stores it if he's not online at the moment, not in the air. So it's pretty straightforward. So now I'm going a little bit into the data format. There are the main types, the basic types that you have is SMS deliver, which is the format of an SMS message as it arrives in your phone when someone has sent a message to you. There can be a report of a successful reception. The same way as the other way around. The submit message is the one that you submit from your phone to the network. And you can get a report back in how it's progressing through the network, if it's pending or if it's been received by the recipient. And then there are some comments and status things to see how the message is. And why is that? Because you can have like overlapping SMSs. You can send an SMS and you can send an SMS with the same ID later, and it can be overridden. So that's an option that you can have. So you can have like updates, and if the message is no longer valid, then there's no need to deliver it anymore, so it gets overridden with a new one. So if we look in detail, and I hope this is a bit readable, it's a whole list of fields that get set in a submit message. And I just want to go over it and talk a little bit about issues, because it took too much to split this all out, but there are interesting fields in there. The first thing is the message type indicator. Okay, that's a pretty simple thing. It's not so important for this explanation. The reject duplicates has to do with sending multiple messages with the same ID. Then you have a validity period format. You can set the validity period, so the message maybe cannot be delivered in like a day, then it may be discarded by the SMSC. Later on there's a validity period field, and that can be absolute or it can be relative to the current time, for instance. So there's a format field. Then there's an interesting field, it's a reply path. What can happen is that you can force the recipient to use the SMSC that delivers this message for you also to be the returning SMSC. So it's a bit like strict routing, source routing. So you can set the way it should be replied. I'll get back to that later. Then you have user data header indicator. This is a field I'll get back to in the next few slides, there's a separate header field that can specify special information about what type of message this is. So the normal use is to send, you know, hello, I will be home later or something. But you can also send ringtones. In Europe, one of the killer applications at the moment for SMS is the ability to send ringtones, logos to other people, and you can compose your own. And so you have now the top 20 in ringtones, and people pay like $1 for them. I mean, it costs $1 for you to send a ringtone to you, and there are subscription services going on. So, and those are much more complicated. They contain binary data, and user data header is used for that. Status report request is to signal that you want to know what's happening with your message. Message reference is the number that you gave to it, so you can identify this message for later purposes. The destination address is the phone number that you want to send to, but there's a whole numbering plan, so there are also other possibilities to send. Protocol identifier, I'll skip for a moment. The data coding scheme, this is telling what kind of format is this message. So is it 8-bit or is it 7-bit encoding? But it's also for telling if this is an indication that there's voicemail waiting for you, or if there's an indication that there's a fax waiting for you. It has all these options to identify what kind of message it is for you. Another interesting thing is that there's one option there to set so-called flash SMS. Flash SMS is SMS that doesn't say message received, do you want to see? No, it's immediately displayed. So you don't get an option to say I don't want to see it or something. It can be interesting if it's you know, a malicious SMS. Okay, validity period I talked about, and then you have user data length and the user data, which is the rest. For deliver, it's more or less a mirror. What you'll see is in the original and in the submit, to go back, there was no originating address or something. So the originating address is determined in the SMSC. There's no way for you in your phone to set another originating address. So the SMS level takes care of that in this case. What you'll see in the deliver is the opposite thing. You see the originating address in this message. For the rest, they are the same. More messages to send can mean is part of concatenation possibilities. I'll get back to that. Status report indication, it's all the same. Is there another one I want to talk about? Oh, the reply path indicator. This is the one that if it's set in the sender, and there are some rules for the SMSC to modify this bit maybe, but what I've seen is they let it through, and that means that in the end the recipient gets this flag, and if it's true, it depends on the phone if it uses it. What I've seen is that my phone will use it without asking. So if you have a rogue SMSC, like this. Okay. This okay? Whoops. I'll keep it somewhere here. Test, test. Test, test, test. Yeah, this is better. Okay, where was I? Reply path indicator. Anyway, okay, so if you manage to send an SMS, get it on the network with the wrong SMSC address, then you'll get the possibility to intercept the reply to this message. And why is it interesting? A whole lot of systems are doing challenge response kind of stuff with SMS. So if you can intercept the reply, the whole thing becomes much more interesting than if you can only spoof SMS. But I'll get back to that in a later bit. Okay, there's timestamp stuff that's not so interesting. Okay, I said I would get back to the user data header. So how does it work? It's like a concatenated field. Basically, you have total length, and then you have the length of the header. Every element in the header has a type field that says what it is. It has a length, and then it has some parameters. So you can have like several concatenated next to each other, and they get interpreted in the phone and acted upon, and then something may happen. The interesting part, of course, of the user data header is the types of fields. What can you do with it? First of all, you can concatenate the messages. You have the possibility to chain them together and send them as like fragmented packets in IP. Of course, you can get all the difficulties that you have with fragmented packets in IP space. It's starvation attacks, resource problems. If you send like 254 messages to your phone and don't send the last one, you won't see anything in your phone, but they will be in your phone. Only with the last packet, the whole thing gets wrapped together, and your ringtone arrives. So, and you can send these messages even with like, at least to my phone, it's a Nokia, with just character-based. So you don't even need the whole header stuff. The Nokia will even do interpretation of the ASCII content of the message, and also interpret it as if it were user data header. So it's pretty strange way. There's no indication on what timeouts there are, how the resource allocation will be if there's not enough memory anymore in your phone. So I have no idea how it works yet. I've not sent enough messages to fill it up. So what more do you have? SMS message indication is not so interesting. What is interesting is the 8-bit port and the 16-bit port. These fields are used to make an SMS message more or less like a UDP packet. And a bit later we'll get in the web area, there's a type there too. But what it's used for is all these services that they built on SMS, like ringtones and logos and bookmarks and I don't know what. They are actually services listening on a port. So what you do is you send a message to that port number, and then the service in your phone will take this message and start interpreting what it is according to what service it is on that port. So you have actually got a ringtone service listening on port, I don't know, 1581 or something. So it's a bit like the IP equivalent. Okay, then you have some SMC control parameters. That's not so interesting. There's also a field WCMP, which is related to WAP, which is also funny. So now suddenly you get in SMS specs, GSM specs that has nothing to do with WAP, suddenly specifications that are needed by WAP. So why the link to WAP? WAP is normally it's doing UDP. So your phone is just talking IP and doing WDP, which is really UDP. But SMS can also be a bearer for WAP. And in that case, all the packets that are going back and forth are SMS messages, and they act like UDP packets. So you get the same thing with ports, only then they are for the web services. but they needed an ICMP equivalent, so they call it WCMP, and invented a field for it in the SMS message also. And if you get back down, then we have the SIM toolkit. I'll get back to that in a moment. And then some specific use for phones. So this is pretty much the most interesting part of the SMS message. This is the part where you really get applications working with the message, interpreting the message, and bound to make mistakes with the message. I talked about ringtones and logos. It's really, at the moment, a spec between Nokia and Ericsson. What they do is that they have this specification, which is also a bit fake and a bit proprietary, and it's using the services that I mentioned. It's also doing the business cards, so you can have your, your friends and his telephone number and his address, and then you can send it over an SMS, and it will be immediately interpreted by your phone, added to your phone book. So what you get is you see the message on your phone, and the only thing that you can do is view. Mostly you have only limited information, so you don't get all the information, a name or something, and then you can say accept or discard. That's all. And you can't move on. You can't say, okay, maybe later. No, at that point you say, accept, discard, and if you discard, it's gone. Accept, it's go in, and then you can use your phone normally again. What they're also sending is configurations for web. Web needs a whole set of settings to work properly. Specifically, you need an IP for the web gateway, you need a telephone for the dial-in, you need a username, password for access control, and all the starting URL, and all that information is a lot of work to type in for users. So they do like remote provisioning for the phones, specified over the air. That's what OTA means, and let you send SMSs that configure your phone for all these settings. And again, all you'll see is a name that you gave to it. So if you send a message with one of the major providers and say major provider update, and you send it to all the users, all they're going to do is say, okay, accept, and override their settings with your gateway, your phone number, your login, and you're the man in the middle. So again, it's not so much all the deep technological stuff below it, but it's the user interface that's a big problem. Okay, a little bit about this short message service center. As I said, it plays a big role in where the message goes. The mobile phone or the GSM modem is not the only way to interact with that service center. There are a couple of companies that are quite big in the SMSC world. CMG, Nokia, Sima, Logica. They all made their own SMSC, and of course they all made their own access protocols. So you have like now a document that's in the GSM spec world that lists all these protocols as appendices to have all the different people using all the different gateways be able to talk to them. It's pretty weird, and it's again pretty much of a problem that there are so many, and there are so many configuration issues that there's a whole bunch of possibilities. I looked mostly at the CMG and at, let me see, the Sima one. And what's funny is that these protocols are also used for the general public to do, PC-style modem uploads of SMS messages. So someone that doesn't have an SMS phone still wants to use SMS services. You have an analog dial-in and you can just send your message. What they do is they have these proprietary tools to do that, but underneath they speak the full protocol of these SMSCs. And it's pretty nice because you can specify all these fields that I was talking about with your own custom software, including source address, because these protocols don't speak the precise submit message. What they do is speak a bit of a higher level, like your phone would, or like the GSM layer would, and it would allow to set source addresses. So you can set any address that you want and spoof SMS messages as anyone. But you can also do all the tricks with you use a data header, and you can fiddle with the bits, and it's pretty fun. And you can also have more advanced features that you don't have if you have a phone. What you can have in the CMG is you can send a message to someone and have a notification sent to a third person. So you can have a spoofed message, and you get a notification that your spoofed message went to the right person and was received. So I think that the problem with these protocols is, again, there are also access controls defined. Some parts you can only do if you're, have a certain password. Most is password, username, password protection. But again, all the operators need to do all the configuration. There are so many different that no one precisely knows the functions, and a lot of mistakes will be made. A completely different thing. Every GSM phone is equipped with a SIM, subscriber identity module, which is basically the smart card that's in the phone. The smart card in the phone holds some of the secrets so that you can be securely identified to the network. But it's a smart card, so hey, you can do a lot more with a smart card. Smart cards are nice. There's a whole standard for how you can write stuff into it and read from it and protect it with PIN codes. And it's tamper resistant, so it's a nice thing. Why not use it for more? So one of the things that they came up with is an API and a protocol to talk to the SIM. And even for the SIM to talk to the phone. So you can have dynamic menus in your SIM card, and the SIM card can tell the phone, hey, display this menu for me. It's pretty extensive, and maybe that's not all that spectacular, but one part is that you can talk that protocol over SMS to your phone. So why did they do this? They want to have operators be able to update their user base with these dynamic menus. So they have a new service, and they can write in your phone a new menu, and you'll have that new service in your phone. There's a protection with PIN codes and a secret that the operator needs to know, or even with cryptographic signatures if the SIM card would support it. All in all, they did think about security, but the scary part is that what happens if the card hasn't been protected properly, if someone chose to write some information without a PIN code. The protocol goes so far that you can write APDUs, which are on smart card level, the command strings directly from an SMS. So you fully control what you can send from an SMS to a smart card. Again, sometimes hardly with the user knowing what's happening. So the risks are that all the mistakes that are made in SIM cards become remote risks. And I've heard from a bank in, I think, Finland, that was using credit card information in the SIM, and they just wrote it in a field, in an elementary field, but didn't protect it. So with this kind of technology, you can now read that data from the SIM card remotely. Okay, some threats that you can see with SMS. Spam, that's one of the things that we really see in Europe now is just people getting spammed now in their phones. Last year with New Year's, on New Year's Eve, everyone received an SMS message from one of the big phone companies. Hi, please call me now, and a number on it, which was a nice high billing number. So all these people thought a friend called and wanted to say hi, Happy New Year, and they all called the number, and someone got rich. So it's basically the high volume thing combined with things like calling and charge numbers to create effective multiplication and make money that way. And all the public SMS gateways, because SMS sending through web servers and email services is also increasing lately. All these services are being confronted with spammers and people finding ways to automate supposed to be manual entries of SMS messages. They are now even doing the thing I also saw it in Yahoo, where they may make a graphic number, and then you have to retype that number in a box. So to automate it, you would need to do some OCR or something, and probably people will find out ways to do it. So spam is one of the big problems. As I said, spoofing. Source of an SMS message isn't worth anything. I mean, everyone can spoof SMS, and it's known among the operators. Only the people using it still think that everyone that's sending an SMS is really the one sending the SMS, leading to the ideal, more or less socio-engineering attack. I mean, you can have people jump up and down based on the sender of an SMS, just the same as with email. It's in that sense, it's basically the same thing, only it's even much harder with SMS to protect this because of the roaming capabilities. I mean, users can be everywhere, so no one can filter on SMS source or something. There's nothing like that, like ingress or egress filtering like in IP. Source of SMS is not to be trusted and basically worth nothing. The only exception to that is for all the users that stay within one SMS, one operator. As long as that controllable situation is there, the operator has a possibility to check who is dialing in and sending his message from where, and you can make sure by using alias numbers that the message don't go outside of your network and also cannot be sent from external networks to your network. So in that case, you have some possibility of limiting the spoofing of the source of messages, but it's pretty hard, and I wouldn't build systems that depend on it. As I said, spoofing is one thing, but you want to have a reply too. Then you get the situations where people are sending messages to a service and need to reply to it to confirm their action. So in this case, you can send a message to someone asking him for his password, and his reply will get to you. So you spoof his boss or whatever, and his reply will go back to you also. And that is a strong point for attacking. And then another thing is, of course, the virus. I mean, SMS virus is, well, I think the worst thing that could ever happen to phones. Imagine that Nokia, who has like, I don't know, 30–40% market share, if there would be an SMS that you can send to a phone that will be resent to all the numbers in your phone book and then kills your phone. You don't want to know what the damage to Nokia will be if they have to recall all those phones. And the question is it possible? On the one hand, okay, you have the monoculture, you have the interpreting features of the phone, all the web stuff and the ringtones and logos. So that will make it easy. However, there are so many versions of phones, and embedded systems are typically different from the software that we have known like in the Microsoft world. That it might not be as easy as it looks. Generally, it's hard if you have an exploit in Unix or in Windows, and you have like to deal with 3 versions. To get it to work for all the versions is pretty hard. If you look at Nokia, I think Nokia has like 5 to 10 different models, or maybe even more, 10 to 15 different models. And every model at this moment has like 5 to 10 different software versions. you don't update your phone like you would your PC. You need to go to a service center because they need to do a cryptographic update of your phone. So it's not so easy to update, but the versions are out there and delivered. So if you do all the permutations of all the versions, then you can see the problem of creating a virus that's really, you know, robust enough to kill all the phones. So that's good. So to give a summary of SMS, SMS is much more than just text messages. It's much more sophisticated. It's getting a lot of features, and it's bound to open holes. I think the biggest holes will be crashing of phones. I don't think the virus will be that likely. It's very much suited to bulk applications. So if you know a scam where you can make money from the reaction to an SMS, it's profitable to do like the bulk application and find some operators that have a leak or an open system and abuse it to send a few million SMSs. And the trustworthiness, as far as the sender is concerned, is worse than even with the standard email. Okay, are there any questions on the SMS stuff? Okay. Sure. Not from your phone. You cannot send forged SMS messages. Yeah, the reason that you can send it from your phone has to do with the way your phone talks to the network, and that layer of the protocol uses the submit and deliver types that I've shown. So there's no possibility to set your address. It's inferred from your call what your originating address is. As soon as you start talking to the SMSCs through other means, then you can spoof the messages, or you know, and yeah, you can pretty much be an SMSC in a lot of places. I mean, the GSM world is like worldwide, and the GSM operators have no way to you know, block people out of it or something. So if you find one operator that's, you know, doesn't care on your spoofing, then you can spoof in the whole network. Or you can send it, but you cannot spoof the originating address. Sure, you can send the Nokia phones. They have an AT command, AT Haas command interface, and you can just send the PDUs that I was showing, the SMS submit and deliver. You can just build those and send them off. So you can pretty much set every bit in the message that you want. No, because when you get in that level, you're in a GSM network, and there are issues with the GSM level also, but that's another story. Because then you also can maybe even spoof phone calls or whatever. So it's in that sense, it's S7 signaling, and you're in that level. So that's outside of this scope. So. There was someone in front?
Yeah. You mentioned that it doesn't time out fragmented messages. How much memory is in these phones? How hard would it be to fill up the memory with a bunch of fragments sitting there, doesn't it?
Well, it's not so much that it doesn't time out. It's more that it's never nowhere specified how it's supposed to work in the phone. So there's no one that says you should time out after this or something. So it's completely up to the phone builder how he deals with it. And well, generally, if you leave it open, you know how it goes. People do it or don't do it, and you have to test to see what happens to know what works. So, and it can well be that they don't time out, or it can well be that as soon as, you know, the memory allocation sees there's not so much memory anymore, that it just discards them. It could be. I have no idea how it works. Okay. No one else? Okay, web. Okay, I'll go into a description, then I'll walk through the protocols, levels that are there, talk a bit about the infrastructure issues that come up when you start building stuff like this, talk a little bit on WML and WML script. I forgot to say that I changed my presentation a bit, and the biggest bit is in the web stuff. The new presentation is going to be or is already online, so you can download a new one. And it will also have much more information in the notes on resources where you can find stuff. So I extended it quite a bit from the version that's printed and was online before, if it was. So what is web about? As I said, it's HTTP and HTML, but then completely warped around and converted for small devices. And what they did is they took all the levels that are involved in you know, normal TCP and HTTP and HTML, and all threw them together and redesigned it and called that web. So web is everything. It's a network architecture, but it's also a protocol and it's also the language. The big difference in the model as we use internet today is the web gateway. I'll get back to that soon. And another thing, the specifications are at the web forum. This is the model that they use. What you see here is the client, which is the phone or the device, the gateway, which is a computer, which is reached by using a connection, and it can be dialing in, it can be the SMS as bearer, it can be other switching technologies. Once it reaches the gateway, it has a special protocol that it talks to the gateway with, and the gateway is the one that goes out on the internet and retrieves whatever you want. So they really split the tasks that are normally done in one PC in two systems, one your phone, and they try to offload stuff to the gateway. What also is happening in the gateway is that they're doing encoding and decoding of the textual stuff into a much tinier binary format. So they take that network topology and then they design a network layer, a protocol stack to be used with it. And what I'll do now is walk a bit through the layers and explain a bit what it's doing. In the lower layer you see the bearers. Again, GSM can be used, CDMA, SMS is also one of them. I'll start with the lowest layer, which is really not much of a layer if you're using IP. How does it work? The phone, if I'll go back twice, well, 3 times. If you see the client connecting to the gateway, actually what is happening is that your phone is just dialing in and doing a PPP dial-in connection, PAP or CHAP, and it's just connecting over IP. From that point on, between the gateway and your client, there's just an IP protocol, and you can scan your phone. It's just you know, it's just IP. It doesn't do TCP, only UDP, and generally it crashes if you use Nmap. So, and if it doesn't crash when you use Nmap, you can use tools like ICIC or ISIC. It's doing random IP stuff. And generally, if the phone receives that kind of data, it goes flat. Well, it's a thing with all IP stack implementations. I have never or almost never seen an IP stack implementation that was done from scratch and was stable. Generally, it breaks down. I've seen, last thing I saw was Nokia ADSL, and again, it just flops over every time you know, scan some stuff through it or use ISIC or something. That's the problem with all these kinds of technologies, especially if you're doing them embedded. it's hard to do an IP stack right, and especially if you're doing the higher level protocols. And generally, no one does it right the first time, and no one is testing properly if it works. So again, the WDP layer is pretty much just UDP. WDP specifies that it needs a source and a destination, and it might do fragmentation, and it needs a controllable protocol, and they all specified it such that you can use IDP and ICMP for it. But as I said, you can also use SMS. I don't know what you need to expect data bandwidth. It's, I think, like 100 bit per second or something. So the next layer, the much more interesting layer, is WTLS. This is probably, if you've heard of WAP, this is the most named layer of the WAP protocol, because it's providing the encryption and authentication of WAP. If you look at the layer, you'll see that it's pretty low. It's below the session level stuff. So it's on a different place than with normal SSL. Normal SSL, you set up a session, a TCP connection, and over that session, there's an SSL connection. In this case, the SSL or WTLS is below the transaction and session layers. So it's pretty low. Anyway, what it does is pretty much the same as SSL and TLS. It's providing encryption authentication. It has the whole handshake and infrastructure to do exchange of a secret. And in 1999, I think it was Markku Juhani Saarinen, I'm not Finnish, so I have no idea if I pronounced it right, did quite a complete research of WTLS and looked at the issues that what made it different from the normal TLS, and came up with, like, there were more than this. I just named a few problems that he identified in WTLS. One of them that I don't mention here is that they were using 40-bit DES, where they still had to do the parity stuff, so they ended up with like 35-bit DES or something. So completely worthless and not even worth writing down in a spec, so pretty sad. Things that you see here is they had the PKCS problem, which is the error messages that you can use as an oracle. Unauthenticated alert messages, so you can break off sessions of a user. It was not really not all the points were as bad, and I think most of them were fixed in the newer specs. But it's pretty much the only work that has been done on analysis of the crypto level. What you can say in general is that you still have the problem that the keys are stored in the phone, which is, you know, one big space. No phone has like process levels and privilege levels. It's just an embedded system, one big space. If you can get hold of a phone, you can just read out the flash memory most of the time, so you can read out all the data. I have no idea if they even encrypt the key in the phone. However, there are some new standards emerging in the WAP 1.2. There's a spec for the WAP identity module. It's another application that's on the SIM, and it's using the SIM as a crypto processor. So it can use the signature functions and the encryption functions of the SIM, which is a big improvement.
Question.
Okay.
Sorry.
Is there a standard right now for encryption on the wireless solution? Is there some kind of equivalent? I've heard rumors of equivalents of phone encryption, which I've yet to see proven. I've heard rumors of triple DES encryption, which I've yet to see. Is there a set standard right now that's industry-wide accepted?
For WTLS, I think it's RSA. Basically, I think it's RSA and what's the other one? Yeah, that's RC5 is for the encryption and RSA for the authentication part. So that's basically it. I think it's just RSA with RC5. Yeah, so that's all that's being used now.
And there's nothing that
Also for the WTLS? Yeah, I've mostly seen mentioning of RC5. I can't even remember seeing triple DES anymore.
one of the questions I had goes to the phones that have multi-use and they can go into RF capabilities as well as access cell phone too. And that's kind of where I'm concerned with this. Is there a standard that's set up for those multi-use type of phones?
I don't think so.
RF,
This is all. I mean, it's set up so that it's. I mean, it's not fixed, but for the implementation that I've seen, it's like I said, RSA. But also, these specs don't go from a standpoint that there's anything else but this. I mean, it's for that the focus of the web specs is just this is us and this is how we do it and this is safe, and there's no consideration of other environments next to this. So I don't think that there's any, information on doing shared secrets or or crypto for this kind of devices. There was another point that someone told me today. I just saw that there was an issue with web gateways that are now have a problem with the way they certify the certificates of the server that they are accessing. So the web gateway or actually the WTLS, you talk to the gateway. You don't talk to the SSL server or the HTTPS server on the internet. You talk it to the gateway. So they call it the gap of WAP or something. In essence, you terminate your secure session in the web gateway, and then the web gateway will set up another session to the HTTP server or HTTPS server. So you have the problem of no end-to-end security, making a man in the middle possible. But I was going somewhere else. I was talking about the problem that they now identified is that the web gateway is not properly certifying the HTTPS server on the internet. It looked at, or it does look at the root certificate, but it doesn't check the certificate of the site itself anymore to see if it matches the site that you were requesting. So the signed name of the server can be different from the one that you were actually requesting, and you will never get a complaint in the phone. So that is also a pretty bad mistake, but that's pretty much the mistake of the web gateway not doing proper checking. The other way, the other one, what I said, is the user interface problem. I mean, how are you going to see that you're secure, or how are you going to explain to your users what to watch? How do you prevent people from sending bookmarks over SMS with your so-called secure site, and actually it's visiting an unsecure site that looks precisely like yours? You name your bookmark again like update or something, and everyone will add it and use it instead of your original site. And how do you tell the user that he's not talking to your authenticating or authenticated server? So above the WTLS, there's the transaction layer. This is a really pretty basic thing. It's about specifies about 3 or 4 packets, and basically is to get reliable connections over an unreliable layer. So what it's doing, it's adding a transaction ID, and the server is trying to figure out if you're sending an old one that went missing, or you're sending a replay, or if you are actually sending a new packet or so-called invocation. It doesn't do any security. It's really the bare minimum of a protocol that you need to do reliable. And even then, it's not resistant to any malicious attacks trying to get the protocol out of state. These are the basic packets that are in use. There are 3 classes. I had them here. So you have unreliable. This is just you send a packet and you don't care. If it gets there, it gets processed. If it doesn't get there, too bad. Class 1 is reliable. So you do get acknowledgement, but you don't get a result. So you only get acknowledgement that the packet was processed on the other side. And the second class is reliable, but with a result. So you first get a result, and then you have to acknowledge the result, so the server knows that you processed the result. Okay, I don't want to go too deep into this, but we did some testing on this level. We wrote some tools to play with a few of the web gateways. And as soon as you can do spoofing, it's pretty easy to get this protocol in a state to do denial of service, because you can set the transaction ID to the maximum level while the actual client is still on a lower level. Normally then the server would get into a verification protocol where it tries to figure out what you want to do. And at that point, because you're spoofing, you send another packet and you get it into a state that the server thinks you're in the high packet range, the high TID range, but the client actually is still on the lower level. And in that state, you get a denial of service. The server won't accept any of the lower TIDs anymore of the client. Okay, above the WTP of the session protocol layer, the session protocol is a bit of a weird layer because it's both trying to do sessions, maintain a state over a longer period, and at the same time it's trying to do the whole HTTP GET POST thing in the same protocol. Again, there's no mention of security in this protocol. It's all depending on WTLS. And I should have mentioned that WTLS is just purely optional. I mean, you don't need to use WTLS at all. And for normal surfing, you don't use it. So it's only for HTTPS that the WTLS will be used. So that's one of the big problems that I see with the whole web protocol specification. Basically, it should be like mandatory WTLS or something to create some kind of reliable protocol. The WESP has a connectionless and a connection-oriented mode. In the connection mode, you get a session ID from the server, and that session ID is the ID that ties you together. You can have several message types. You can set up a connection. You might get a redirect to another server, so you can have multiple gateways. Then you have the methods itself, so get and a post and a reply, and there's a whole set of encoding. So all the headers that are in the HTTP protocol are described here, and how to encode them in the requests. You can suspend and resume a session, and then you can have a push. A push is where the server can send unsolicited information back to the client, which is always interesting, of course, in a situation where you want to attack a phone. If we look at WSP, there's nothing specified on the session ID. So I've not done much testing on it, but I suspect that it's incremental. So again, if you can do spoofing, it's not really reliable, and probably you can get into sessions and break into sessions and maybe even push data to a client. But I think this is still an area where you could do some research. There has been some research in the reliability of the web gateway handling of these messages. It was part of a project called Protos. What they did is basically have this testing tool and environment, and they took WSP as a case for their environment and tested several gateways in how they could handle messages. And this was not done with a very, how do I say, a predetermined way to modify the messages. It's much more like length and overruns and randomization in the WSP protocol. But that's what the test showed, that the early gateways that were out there were pretty unstable, weren't able to handle weird packets and stuff like that. Just as I said, with the IP stacks for embedded systems, the same goes for these levels of for the gateways. Generally, what you see when protocols are there, specs are written, people start implementing them only functionally. So the conformance spec always say it should do this and this and this and this, and no one is testing, but what happens if I send this and this and this? All the stuff that it's not supposed to do. And what you see is then generally it's still, it all crashes on those, then people fix it. Kennel, which is an open source web gateway, which is a pretty interesting project to see how it works and to play around with the technology. You can use it with your own dial-in and your own web phone and not be tied to any telecom operator or anything, and play with web if you want. And an example is that Kennel also still has a problem if you just max out the threads. It starts threads for every session that you want to start. Actually, I'm not sure if this should be in the WTP level or the WSP. But you can send, invokes or session connects, and the threads go up, and then if it's max, it just bails out. Then we get to the top layer, which is called the application environment. What they did is first you had the browser, which was pretty much the environment. The browser is the environment handling the WML and talking the WSP and TP protocols. What they added now is WTA, which is a telephony application interface. Because you have a phone, you have all kinds of functions in your phone that you might want to access, like call out or have voicemail handling. So they define this as another user agent in the environment. And that's how the user environment or application environment developed. Services that are in that environment are the handling of the WML script, the libraries that are there for WML. When I start talking about WML, I have to admit I'm not really much into this yet. If we look at WML, it's an XML type of language. It is in that sense pretty structured. However, it doesn't work like HTML in the sense of frames. It doesn't have pages and frames. What you talk about in WML is decks and cards. A deck of cards is, every card is one screen, basically. Also different from HTML is that you can talk in variables from one card to another card. So one card can send variables to another card. So you have some kind of low-level, programming is a big word, but interaction that you don't have in HTML sec. It can handle images, which is also a specific binary format for web. And all the WML code is compiled in the gateway. Actually, I always thought that you can also put the compiled code on your server and have the gateway retrieve your compiled code. I tried to confirm it before today, but I, for some reason, haven't been able to do it. So I'm not sure if it's true or not. Why is it interesting? On the one hand, it's interesting that the gateway is processing your code. It's your WML. Any mistake in the compiling algorithms are vulnerabilities to the gateway. It would be a potential attack to the gateway to have malicious WML and have the compiler freak out. On the other hand, if you have you want to attack a phone, you do want to have compiled WML that is not like modified or checked by the gateway. So if you can get a gateway to download your compiled WML to the phone directly without interference, you have a more direct attack vector to the phone. So that's why it's interesting to know if it's one or the other. WML script, it's called the JavaScript equivalent. However, it's much less than that. Excuse me. In a sense, it's the good thing about WML and WML script is that it's so primitive. That means that it's less complex and there's less things to go wrong. WML script is located in separate files, so they are also compiled in a separate fashion from the WML. One scary part of the WML script is that they are building extensions to interact with WTA, the telephony application in your phone. That means there are provisions to start calling from WML script. So it pretty much depends on your phone, and I've read the latest spec on WTA, which has now one big security chapter. It's the biggest security chapter except for WTLS that I've found in the web specs. And I suspect that it's because someone got really nervous because there were some phones that would do calling without user confirmation. So you could have a WML script go call someone without any confirmation from a user that was okay to call. I'm not sure if you heard from the iMode case in Japan, where there was a game that called out the alarm number and the whole the alarm system went on its belly because so many people were playing the game and calling out to the emergency line. On the other hand, if you have like a charging number for a few dollars a minute, might also be interesting to have a lot of people serve to your site with that kind of WML script. So now in the specification there's very explicit that user confirmation should always be there. And well, that's a good thing. The question is how many people will actually implement it. So JavaScript bugs all over again. On one hand, yes, there will be issues. On the other hand, it's much more simple, which is good. Okay, some other general problems I've seen with the web is the problem of maintaining a session. Because of the gateway that's in between, it's very hard for the application builders to know who they're talking to if they're not using basic authentication or something. So there was also no or very limited cookie support, so there was no way to track a user through your site. So what people are starting to do, of course, is encode the session in the URL, which is not always safe. I mean, URLs get stored, bookmarked, and if that's the level that you trust, then, and especially if it's a site that's plain on the internet, you get all kinds of other attacks. What I've also seen is user identification based on a modified web gateway, where they use the caller ID to figure out who is who. Might work in a closed situation, but again, in this case they were passing the number in the URL to the site, which was on the internet somewhere. So basically, if you serve to the site and specify the phone number on the URL, you're the user. So pretty brain dead situations. So this is a problem. I did see there's now cookie support. I'm not sure how well it is. And again, I think the move to WTLS, and especially with WIM, where you can do user authentication based on the SIM card, that would be basically the only way to do proper use of web. So WTLS, as I said, is basically the most things that you see with looking at web systems. However, there are also much more interesting things because it's all IP. You can just dial into a system and be one phone with your computer. So you can simply start scanning from your dial-in, see if the gateway is properly protected or not. You can spoof messages, maybe if there's no proper filtering as anyone else, to the web gateway. Also, the web gateway might be listening on all kinds of other ports, or the dial-in may be listening on SNMP or whatever. Just because people don't realize that the fact that I can scan from my phone doesn't mean that I can dial in with a computer. Generally, the fact that we are dealing with phones, people are very confident that there's not so much you can do with a phone, so it won't be so bad. Oh, sorry. You just called a number that you get with your web specification, and the usage, it depends on the bearer of your web. But all the usage in Europe now is over IP, and what you do is you get an ISDN line and you just dial in. You need V120, so it's a bit of an odd protocol. But you can just dial in with your computer and be on the dial-in, and there's no way. What you can also do is use the new phones and use the AT interface and just call as a GSM modem and have a data connection. And you set up a PPP call and you're on the dial-in.
Now, the phone has an IP address then, so
Yeah.
the router was free before the gateway.
Sorry? Yeah, what I've seen so far, it doesn't need to be, but that's generally you have to dial in with a router in front. And what you should have is a router, because you should be filtering there. You should be filtering on the IP that the dial-in line needs to have. You need to filter the web gateway from unwanted traffic.
There's PPP between the phone and the router, and then you have IP going all over. Is that what's going on?
Yeah, if you see the router as an access router, and then you have PPP to there, yeah, and then.
Is that what it does? Is that what the phones are actually doing?
Yeah.
Yep.
Yeah. You have a PPP session, and you just get a number.
Well, because I have a Verizon phone that's web enabled, and I noticed I didn't quite exactly know what some of the numbers meant. I presume the router and the phone have a PPP connection, and then an IP tunnel is established from the phone, the WAP gateway. Is that? I'm asking you if that's a fact.
As I see it, you get a number for your web setting. You get a phone number. That's your dial-in, like a normal dial-in.
Really? Okay.
It works like a normal dial-in. So your phone gets an IP number to the access router or whatever is there. Then it depends on the setup, if you have another router to do the filtering or if it's the same system. But your phone is just like a normal dial-in, just like your normal home PC. It's normally dialed in. The only thing is that the protocol that the normal gateways talk and that your phone talks is V120. But from then on, it's just IP. So you can just dial in. And you can just, from then on, you can just do the scanning. So in this case, you can scan the web gateway, you can see if there are services open, you can see if the intermediate router has stuff open. You can try spoofing. The second phase is that you can do, if this is a web gateway going to the internet, you can serve to your site. So you can set up your own web server with, I don't know what kind of modified content, and have the web gateway get that info for you. So the web gateway is influenced from two sides. Now I have to say that I've not seen any attacks that use this kind of modified WML or anything. But it is possible. The good thing is that WML is XML, so it has quite strict checking on correct information. But in theory, this is a possibility. And the next thing is, of course, that you can attack the phones. All the phones will be dialed in at that web gateway. So if there's no proper filtering, you'll see all the IPs of all the other phones that are out there. And you can access them. And what you'll be seeing is that you can do the same thing that you did with SMS, but then over UDP. You just send UDP packets to ports on the phone, and it will be listening on the same services, and maybe send fee cards, ringtones, and whatever to the phone. I don't think it's doing it yet. I think there's still a difference between the SMS level there and the UDP level. But also, you can, if you can spoof the web gateway, you can access the web gateway. So you can have the phone, accept data from you. And if nothing else, you can crash it because the stack is so bad. So for the denial of service, it's also a problem. Okay, then a little bit on some new stuff that's in Web 1.2. The first is push. All we've seen now is really spool. You get stuff or you post stuff. The thing that's really nice with a mobile device that you have in your pocket all day is that you can push information to it. So they've designed the whole infrastructure to support also push to your phone. Again, there's the danger of user confirmation because the push specifies all kinds of stuff that might be possible. And do I want to have it or do I want to allow it? Who is the trusted party? There's a link to the authentication in WTLS also, but it's a problem with push anyway, and especially on a device where you have a poor user interface to judge if you want to allow it or not. The other one is the WTA. As I said, access to phone functions, and the last is the WIM. For the identity module. So these are all specified in Web 1.2. Here's a little picture on how the push is going to work. Again, they have a gateway. The gateway is at the operator because you need access to the phone on a level. It's also talking the web protocol levels, so WSP is used, and the big problem I think is in who is allowed to initiate. So you have push initiators, and somehow the proxy gateway is going to have to allow. There are some examples on how the gateway should be able to check lists of allowed URLs or not. But the specs are completely vague on how this is supposed to work. So again, all the sensitive security stuff around push, they only focus on the encryption and authentication level, and all the areas where you want to say who is allowed to do what is hardly specified. So I think that will be a problem in the future too. So this rounds up the web part. General points is the protocol or the whole web thing just mixes too many levels. It's trying to do a network thing, a protocol thing, WML specification, which makes it a pretty messy thing to work with and to understand what is affecting what. The specs are pretty unclear on the security sensitive issues. You have a web gateway sitting in the middle, which is pretty much open to attack from a lot of ways. And I don't think there's very much insight in how much you should protect it. And then the user interface interpretation, which is always difficult on the mobile devices. So what will be in the future? As I said, the combination of smart cards and WTLS security, that will be big. We'll see a big increase in number of features, so I don't think it will end with the ringtones. So what you get is a lot of interpretation, so that is a risk area. User interface, I don't see how it will improve except for that PDAs will get into use more and more, but phones in itself are terrible. And there's this version explosion with all the phones, gateways, and web versions, which is also a problem. So that's it for me. Are there any questions? Yes. Sorry?
Why do you still have a cell phone?
It doesn't work here. To play with, basically. Okay. Thank you very much. Bye-bye.